All right, so now that we've learned about forces, we can get into our discussion about Newton's three laws of motion. So again, I'm going to be using outline notes to take notes today. I want you all to, again, copy the notes as I have it here. Make sure you include the topic, the objective in your notes, as well as the date and your essential question. And then don't forget to write your summary at the end of your notes today. So our topic is Newton's three laws of motion. And the objective is to be able to identify and describe Newton's three laws of motion. So the essential question we will be discussing today is, I'm going to get it out of that. The essential question we'll be discussing today is how does an object move according to Newton's three laws of motion? So again, Isaac Newton was a famous scientist. He came up with these scientific laws. So remember, a scientific law is based off of repeated thousands and thousands and thousands of tests. And it basically just, states the way things are, So again, these are laws in nature describing how nature works. So Newton came up with these three laws describing how motion works in our universe. So the first law that he came up with, I'm going to get my highlighter out. All right. So the first law that Newton came up with is he stated, an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. So remember the difference between an unbalanced force and a balanced force. A balanced force, meaning that object is at rest or it is moving at a constant velocity. Whereas an unbalanced force is going to cause that object to accelerate. So that unbalanced force would be, it is interfering with that object's motion or with that object's rest. The first law is also called the law of inertia, meaning inertia is the resistance to a change in motion. So when we talk about inertia, right, let's use this example of this girl on her skateboard. So she's skateboarding. So this is her motion here. Right, she's in motion, okay? And she's skateboarding across and then stumbles upon this rock, right? So she hits this rock. The rock is going to be our unbalanced force. All right, so the rock is going to immediately stop that skateboard. But because of this girl's inertia, she is going to keep moving forward, right? So the rock, while it did act on the skateboard, it didn't act on her. It just acted on the skateboard. So that rock stops the skateboard. Meanwhile, this girl skateboarding still continues to move. So this is what we're talking about with the law of inertia. She wants to stay in motion. No object has acted on her that has caused her to stop moving. Another thing to remember is the bigger the mass of an object, in other words, how much space that object takes up, the more inertia it has, right? So again, we could think about if you are a weightlifter, it is a lot easier for you to pick up, a barbell of weights and pick that up, right, off the ground than it would be for you to pick up a car. I'll draw my car for a second. that car has more mass. It's a lot bigger than your barbell of weights. So it's going to be a lot harder to pick up. I'm going to exit out that. So again, that is our first law according to Newton. First law of motion is an object of motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Okay, let's move on to our second law. So our second law, you guys have actually already learned this when we learned how to calculate the force acting on an object. And the second law simply states force is equal to mass times acceleration. In other words, our second law is our equation that we use to calculate force. Force equals mass times acceleration. So one thing I did want to point out to you all is this little triangle trick that I like to use sometimes when I'm calculating force, mass, or acceleration. So when we're looking at this triangle trick, the main thing to remember is you're going to cover the variable that you don't know. Connect that. Okay. All right. So again, we are looking at F equals MA. So whatever that equal sign is, that's going up in the top, right? So we've got F equals M times A. So that's how we set up this triangle. And we're going to learn a couple more equations throughout the year that we could use our triangle method for once y'all get the hang of it. So when we are using the triangle method, we're going to cover up the variable that we don't know. So I'm just going to, let's say we're solving for M. All right, so I'm going to cover up M. And obviously I'm using a transparent marker here so you can see that. But when I cover up M, that leaves me with the equation M equals F over A. So y'all see that? M equals F over A. And I see that right here as well. M equals F over A. So again, this would work for any of those equations. If you cover up A, you're going to have F over M to equal acceleration is equal to force divided by mass, right? And if you cover up F, you're going to have M times A. So that is just a cute little trick that I really like, and it helps me do some really quick math there. Another thing I did want to point out to you all is that mass and acceleration have what we call an inverse relationship. So an inverse relationship means that as one gets bigger, so in this case, as acceleration is bigger, mass is going to be smaller, right? So think about the difference between you kicking a tiny little pebble, right? You wanting to kick this pebble. Here's you, and here's this little, I'm going to fill this in because it's probably a little bit easier to see. Here's your little pebble with a small little M representing its small little mass, right? If you kick this rock, it's going to have a big acceleration, and I represent that with that big A, right? In contrast, say you were trying to kick a boulder, right? That rock is almost as big as you. It's got a much bigger mass this time. So when you try to go and kick it, it's not going to experience that much of an acceleration. So again, as you increase the mass of an object, its acceleration due to that force you were applying is going to go down. And that's what we mean by an inverse relationship. So again, inverse meaning as one goes up, the other one goes down. So they're inverses of each other. All right. The last law we will go over today is Newton's third law of motion. Highlight that. And I love this law because it rhymes and it's super easy to remember. For every action, there is an equal and opposite reaction. So what this law is saying is that forces act in equal and opposite pairs. So let's think back to, for example, our table, right? You place a box down on a table. Here's your box, right? That box is exerting its weight force, its force of gravity on the table. The only reason why it is not falling through the table is that table is exerting a force, an equal and opposite reaction to that box's weight force. So that's what we're getting at with our third law. Forces like to come in pairs, right? And weight force and normal force. Here's an example. If you're leaning on a wall, right? I know it's weird to think about, but that wall is actually pushing back on you. So we have our action here of you leaning on the wall. And the reaction is that wall keeps you upright. Thank goodness. So we don't fall through the wall. We have those reactions. The forces come in pairs. You leaning on the wall is one force, and that wall is going to exert a force of an equal amount to keep you standing, right? We also see this in some of my favorite movies. I love Marvel movies, so I figured I'd use this example, right? Any rocket, though, uses Newton's third law of motion as its fundamental principle to help it fly, right? So think of Iron Man, right? His action, he's shooting from his rockets in his suits downward on the ground, right? So all this air is hitting the ground right here, right? But he flies because that air is hitting that ground, and that air is exerting an equal and opposite force that causes him to fly upward. So we've got our action and we've got our reaction, right? His action is shooting those rockets down toward the ground, and his reaction is that he flies. So another cool application of Newton's third law of motion. So again, please remember to write your summaries about the Newton's three laws of motion, and remember to try to answer that essential question: how does an object move according to Newton's three laws of motion? And I look forward to discussing this with you all more in class.